And now we are going to discuss about the about what we have discussed so far about earlier classification. It started with French chemist Antoine Laurent de Lavoisier in the year of 1789. He classified elements that were known at his time, that is 9 elements, which also included uh, calorie and another thing, basically 7 elements and 2 non-elements, into metals and non-metals. And it was soon realized that this classification is not good, because more and more elements were discovered, and this idea was dropped. This classification was dropped. Then came German chemist Johann Wolfgang Dobereiner in the year of 1817. He came up with a law of triad. He took set of 3 elements which had very similar physical and chemical properties, arranged them in the increasing order of their atomic weight, and he found that the atomic weight of the first element, when added with the atomic weight of the third element, and the result is divided by 2, it becomes the atomic weight of the second element, like chlorine, bromine, iodine, like that. But that was not true for all the elements that were known during his time, and as more and more elements were getting discovered, it was realized that this does not hold. So this law was discarded. We also discussed about the definition of periodicity, which is the recurrence of physical and chemical properties of elements after a certain interval. Some of the periodic properties are atomic radius, ionization potential, and electron affinity, and we discussed about the definitions. Then we talked about the telluric helix, that is a model developed by Alexandre Émile, that is a French geologist. He arranged elements in a spiral cylinder in the increasing order of their atomic weight, and he found that elements having similar physical and chemical properties, they fall on a vertical line, which was quite an interesting discovery indeed. But it had few drawbacks. First of all, he used geological name. After all, he was a geologist. He used geological names for those elements and not chemical names. Another drawback was some of the components in his table, which he called telluric helix, were not actually elements, they were compounds. Then we talked about Newland's law of octave, which states that when elements are arranged in the increasing order of their atomic number, the similarity in physical and chemical properties recur at an interval of 8 or multiple of 8, like lithium and sodium, beryllium and magnesium. But his theory was not well accepted amongst his contemporaries. But it was a good observation indeed. Then we talked about Mendeleev's periodic law, which states that elements, physical and chemical properties of elements, are a periodic function of their atomic weight, and based on that he arranged the elements. I think there are 64 elements or 63 elements known at his time in a table which he called as periodic table, and he was able to predict some of the elements which were not discovered, and he was able to correct some of the atomic weights which were incorrect at his time. Of course, it had its drawbacks. For example, placing the isotopes and placing some of the metals, some of the elements, which was not very correct according to the periodic law that he came up with. Then we talked about Lothar Meyer. He arranged a table, developed a table like Mendeleev based on the valency of elements. Then we talked about William Olding, British scientist, who has developed a table similar to Dmitry Mendeleev, but Lothar Meyer was not able to predict the unknown elements. Then we talked about Henry Moseley, who came up with modern periodic law. That's all we discussed so far.